Welcome back to day 4. Okay, let's see. So we have an easy problem today. We're given an integer nums and okay, this might be very quick. This might be a very short video. Exactly one subarray. Return the largest almost missing integer from nums. Almost missing? Oh, that, wait. Wait. Hold on. Isn't that just... Hold on, this can't be it, right? Oh wait, it should be max. Hold on. Oh, never mind. I was dumb. Sorry, guys. So it's either gonna be the first or the last digit, because every other number probably appears twice. Oh wait, unless k is actually larger than 1. Should I actually think this through or not? I can do this in ON, which is also already like very fast for n is less than 50. Yeah, I'm just gonna do that. So what should I do? I mean, I could just go through all 50 possible numbers and then go through all possible lengths, but that's too slow. Yeah, I feel like easy problems just test how good you're at for loops, conditionals, and all that basic stuff. But I want to optimize this. So I'm gonna divide this into two cases. If k is 1, right? If k is 1, then I'm gonna need to check if there are any numbers that appear twice. Or, like once or twice. Yeah, any number that appears once in the entire array, you just get the maximum. If k is larger than 1, then it's either going to be the first element or the last element. And yeah, this probably shouldn't be that hard. Alright, so first I'm going to make a count array. It's 50, so it's of size 50. If k equals 1, then do this. For okay, so if count of nums I, or you know what, just skip this. I'm gonna run this 2 times, and then actually -1, because if you can't find anything, it should be -1. Nums I is equal to 1, then return equals max of return num star, and then I'm just going to return this. So that's the first case. Else I would do the exact same thing, but wait, there's no guarantee that k is less than. Okay, k is less than, so that's good. So it's gonna be exactly that for the first part. Then I'm just gonna check two numbers. If int first choice is going to be max of both of them, or nah, I'm just gonna do 1 if count of nums 0 equals to 1, then return is going to equal to that. So instead of having multiple possibilities and I have to iterate through all of them, I just need to check two numbers, because all the other ones will appear in at least two subarrays, which is this. Oh, it's a vector. I can just dot back. Yeah, I haven't used that. Okay, I'm gonna try this. There might be some edge cases. Okay, it got accepted. I'm gonna submit this. There might be some edge cases that I haven't accounted for. Oh, there it is. So k equals 2. Okay, I get why this is giving me wrong answer. Yeah, I think my approach is flawed. I shouldn't have done that. I really don't want to implement, like, I don't want to just follow exactly what the problem is telling me to do, because you know what, I'm just gonna do it. So count this is going to be checking how many subarrays that value has been found in. So I'm going to for every possible subarrays. There, iterate through every subarray, I think. I is going to be the start of the subarray, and J is going to go through all the subarrays. Go through the elements inside the subarrays. So it's going to be count of Then I also have to check am I trying to overcomplicate this shit? Nah. Booleans found. If this is the first time I encounter this number in the subarray, then increment count for that. Then I'm gonna mark that as already found. Then what I'm going to do is I'm going to iterate backwards. What's the range? To 0, okay. As soon as I find a number that has a count of exactly 1, then I'm going to return that, or I'm going to return -1. This is, oh wait, no, I forgot that. What? Alright, I'm gonna submit this again. Yeah, sure, it got accepted. Oh wow, beat 100%. 92% on memory. Okay, I guess that works. I don't like this. I don't know if there are other ways that you can do this more optimal. And you can just watch me overcomplicate this. But I probably don't want to do that. Yeah, that's the end of today problem, I think. Pretty short one. I'm just glad it's not another game theory or stone problem. No, yesterday wasn't even yesterday wasn't even a game theory problem. Bob was there just to watch. 4 hints. What could they possibly be hinting at? Yeah, I guess I was missing the case where k equals n. Okay, hold on, I want to go back to my previous implementation and see if I can, fix it and make it actually work. Else if k, no, this is gonna be the last branch. I'm gonna add another branch here. If k is equal, then just return max element. Is this the correct function? I have no idea. We're just gonna try it. Because okay, can I add a test case on here? I remember you can do that. I remember, oh, you can, okay. 2 k is going to equal to 2. This should return 0. Oh, okay, yeah, that works. Okay, let's submit this. Yup, that also works. Why is the memory worse though? Okay, I'm gonna remove this then. I see. I should not remove that. I thought I didn't use that. But okay. Alright, anyways, yeah. Today's problem was not that hard. I just missed a case here, and my initial idea would have worked. But brute forcing also works because this is very small. I mean, it's an easy problem. There's not much I can say about this. See you guys tomorrow.